Hi, so welcome to the another class of Internet of Things. So in today's class, we'll today study here about the LoRa wireless technology, which is basically for your Internet of Things, the applications for the Internet of Things and the machine-to-machine communication here. So today we'll study here about the LoRa wireless, the LoRa Alliance, its RF properties and the network architecture for this. So basically, your LoRa is long range radio. So this is a wireless technology which has been developed here to enable it has been developed to enable the low data rate communication over long range with the help of your sensors and actuators. So we can put it in a way that it will enable a low data rate throughput over long ranges with the help of sensors and actuators. That means this wireless technology has been developed to carry out the communication over these long range distance with low data rate and low power. Now, if we look at the requirements of your Internet of Things, they are quite matching here with the specifications for your LoRa wireless systems. So we know that here for your Internet of Things, the main issue is that, or the main requirement is also the lower power, the lower data throughput, and using the different sensors. That means the various devices will be equipped with various sensors and actuators here. So this is a technology which is enabled here to provide a platform for the applications which will be driven by your Internet of Things. So this LoRa wireless here can work together. We do cellular networks also. Now we have a concept of cellular Internet of Things also. So basically the operators, which are your cellular operators. So the LoRa antennas can be mounted over those masts, and we can say that this technology here can provide similar coverage like your cellular networks. So both of these can work together here. And we can say that it can provide here coverage like cellular networks. So now after that, we have an alliance, which is your LoRa Alliance. Now, once the network has been developed, that means a platform has been made for running these kind of applications. So, an alliance was promoted or created here so that this LoRa wireless network architecture can be developed more and promoted for the use of your machine-to-machine communications and the Internet of Things. So, this LoRa Alliance is basically here a non-profit organization which works for this platform, for enabling this platform here. So various organizations have came forward and worked for the development of this alliance and this network architecture. So organizations like your Cisco, IBM, etc. have worked here for this long range radio communication wireless. Now, what are the key characteristics of your LoRa Wireless? So basically, first of all, range. Now stated that it should cover here up to 20 kilometers, but basically it covers from 2 to 5 kilometers in your dense areas and up to 15 kilometers in your suburban areas. Now, after that, thousands of nodes can be connected to this network. That means the number of nodes which can be connected here to this platform is like thousands of nodes can be connected here. Again, the low power, the low data rate. Now, your LoRa Wireless has the other network specifications also. That means it has, first of all, your physical layer or the RF interface here and the LoRa network architecture, which is also known as LoRa WAN, wide areas network here. So first of all here we'll study about the physical layer or the RF interface for your LoRa wireless. So if we talk here about the physical layer, so physical layer here for any network is the layer which is actually dealing with the actual transmission of data. That means the layer which is making the direct contact with the outside world, that is your physical layer. That means it is here related to your modulation techniques, the media through which the data is being transmitted here. So same here in your LoRa network, the physical layer is used to make the direct communication with the outside world. That means your physical layer is using here the different sensors which is collecting the information from the world. That means this layer has direct communication with the outside world in order to collect the various data. Now, after that, we have the RF interface for physical layer. That means the various RF parameters which it includes here. So that includes your frequency bands, because all these specifications are made here in your physical layer. The frequency bands, the modulation technique which is used, the power system for the network. Now, if we talk here about the operating frequency bands, so the operating frequency band for Internet of Things, we know that it operates in the unlicensed band, which is your ISM band. So it has frequencies like 866, 868 megahertz, 915 megahertz, 433 megahertz. After that, an functional range of 2.4 gigahertz and 5.8 gigahertz. This is these are the frequency bands for which this network will be working here. Now after that, the LoRa modulation. Next we have the LoRa modulation. So it basically implies here a spread spectrum modulation technique. That means we're basically spreading the spectrum of the narrowband signals by multiplying it within wideband signals. So we are basically spreading the spectrums. To be more precise, it is basically here chip modulation. So that is basically your wideband linear frequency modulated pulses. Wideband linear frequency modulated pulses. So what they're just doing in this technique is that the level of frequencies which is increasing or decreasing. So that is used or that is here made as an advantage because with that increasing and decreasing range of frequency that is used here to encode the data. Whether a more number of data is required to be transmitted or a lesser amount of data is required to be transmitted here. So that means this modulation allows here flexibility for the data throughput here. So it is using spread spectrum, which is your chip modulation technique. After that, the LoRa adaptive link. Now, this is considered here as an adaptive link. That means it should be here adapted to the various conditions here. Now, the various conditions or the we can say that the requirements here, we know that always not a very higher data rate is required here. Low data rate is required. And similarly, the power requirements are also. So that means due to these, a lower bandwidth will be required. Now it has a certain number of bandwidths here, like ranging from your 6.8 kilohertz, 15.6 kilohertz, after that like 31.3 kilohertz, and up to 250 kilohertz. So this bandwidth here can be selected according to the requirements of your data throughput. So that's why we can say that it's an adaptive link here. So similarly, we have an adaptive power control here also, because that also depends upon these things: your data rate, the selected bandwidth, and it can be chosen here or it is adaptive here according to these parameters here. So this is here just about the physical layer or the RF interface for your LoRa wireless systems. Now after that, you have the network. How are the various elements used here? You have now the LoRa network here, which is also referred as LoRa WAN here. Now we have certain elements here. The first element, these are referred as your gateways here. After gateways, next, these are your basically endpoints. These are not gateways. These are your endpoints, like your customer equipment. Now, after the endpoints, we have the next element. These are your gateways. Now, after gateways, we have server and then remote computers here. So these are the elements or the architecture for your LoRa. So this is your gateway and this is basically your backhaul, which could be your Ethernet or your cellular network like your 3G or your 4G LTE systems here. Now, first of all, we have here the endpoints. Now, these Endpoints are those elements of your LoRa network which are basically used for sensing or controlling the data. That means these are basically your data collection elements. That means these are your sensors and controllers. So these endpoints are then connected to your gateways. So the next element for your LoRa network is your gateways. Now these gateways are basically used, or they basically receive the information from the endpoints. That means from your LoRa endpoints, they're collecting the various kind of information. So that means they're used to here process the information of the real world which is collected here by your endpoints. That means your sensors and the various actuating devices in the system. So these gateways are then connected to your service. So these are used to then transfer that information here to server. So this is the backhaul, which basically consists of your Ethernet. It could be wired or wireless or your cellular system. So these gateways are here connected to your server by means of your typical IP networks here. Now the server here is used to manage the complete network. That means it basically checks here for the duplicate uh, packets, it checks here for the acknowledgements, and it's used here for setting the adaptive data rate. So this is basically the management unit here for your complete LoRa system here. Now after that we have remote computers here. Basically these endpoint elements are also remotely distributed here. So this is the wireless interface here. It means this is basically used to enable this communication. That means it could be a long range communication, but with the help of lower data rates and the lower power usage here. Now these remote computers now can then use to collect the various information or to manage the information from these elements, or this can be referred here as the customer or the subscriber platform to get that complete information here. So this is just the LoRa Wireless network, which is used to provide a platform for the Internet of Things applications. The various endpoint elements, which are your sensors and actuators, then the various gateways, which are connected to your service with a backhaul. That is basically your Ethernet or your any cellular system here. So this is your LoRa Wireless system, long range radio. We have studied in this session about the physical layer, the modulation which is being used here, and the various network elements that's making it a complete platform for the IoT applications. So this is all here for today's session of Internet of Things. Thank you so much.